Get ready. All right, 4-8. Okay, last lesson of chapter 4. Are you ready to be done with chapter 4?
Yes.
Yeah? Okay, we're going to do some applications today. Yeah, fancy word for word problems. Applications involving trig. So if you ever wonder, when are we ever going to need this? Here it comes. Here we go. Actually, trig's used a lot in real life. For navigation, for like ships and planes and stuff like that.
Word problem.
It is. Okay, here we go.
You just said that.
We're just going to start. Number 1. We have 4 problems to go through. It says here, the angle of depression, well, that sounds so sad, of a buoy from the top of the bay lighthouse, 130 feet above the surface of the water, is 6 degrees. Now, a lot of times they're going to give you a picture, which is nice, okay? So, here's a lighthouse. I'm just going to draw it like this. Otherwise, it's going to look like a... Okay, so here we go. And it says that the lighthouse is 130 feet tall. And here is a buoy out here. Here's the buoy. There you go. Just going to draw it like that. And it says the angle of depression to the buoy. So what in the world is the angle of depression to the buoy? Well, it's right here. It's this angle. This angle right there is 6 degrees. Okay? And then here's, they call that theta. And then they call this x. All right. So it says here that we need to find the distance from the buoy to the base of the lighthouse. So we're trying to find x. Okay. Now, do you know a little something about geometry?
Yeah.
You do?
Oh, yes.
Yes. You see it. Yeah. What are those? Alternate interior angles or something? Yes. So you have parallel lines, and then you have this coming through, and so those are going to be equal to each other. I taught geometry 1 year, and that was like 19 years ago. So theta is also 6 degrees.
Were you good at it?
No. My first year of teaching was horrible. Okay. So here we go. Now you have, he was here already. Now you have you have to figure out which trig function you're going to use, okay? But look at your angle. We have, what did you say? You said it already, huh? Yes, tangent. Yes, you're going to go opposite over adjacent. So the tangent of 6 degrees is 130 over x. Oh, yeah, sorry. Yeah, I know it looks weird, huh? And then you can cross multiply or just multiply by x. So you have x tangent of 6 degrees, and you're getting your calculator out because you know you're going to need it. And then you're going to divide by tangent of 6 degrees. Now, make sure that you are in degrees for this. These applications are all going to be in degrees. I think they all are. I'm not sure, but all right, so we're going to go 130 divided by the tangent of 6. And x is approximately 1,236.9, what are we in, feet.
Is that a good stylus?
It's pretty good.
Where'd you get it?
Amazon. Ordered a bunch of them. Okay, pretty good. Now, that's an easy one. Okay, we've done that one. You had one on your last quiz about a ladder leaning against a house, and you had to find the length of the ladder. It's kind of the same thing. So let's do a harder one now. Number 2.
Is anything with like tan, cosine, any of that, like, is that all trig?
Yeah. All right, here's a building. Looks just like the lighthouse, but it's a building now. And it says here that from the top of the 100-foot tall building, so this is 100 feet tall. I'll just put it over here on this side. A man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Okay, here we go. Draw this. And they give you a picture, which was really nice. I don't know. You just look so happy. All right. So 22 degrees. So here's the car. It's over here. And then the car gets a little closer to the building. And its angle of observation changes to 46 degrees. Oh, yeah. You know what? It is the angle of depression, too. But they're both going to be the same down here anyway. So it's better to write it down there, I think. Yes. So this is x, and they label this as d. That's x, that's d. So, yeah, the question is, how far did he travel? Yep. Okay, now we're doing right triangles here. Okay? And in this picture, you actually have two right triangles. Let me draw them for you. You've got this one here, the big right triangle, and then you also have a smaller right triangle here. Okay? Now, do you have a plan of attack? Some of you know what you're going to do already, right? Yeah? We're going to go ahead and solve for the distance D right here first. Okay? And then we're going to attach it to our big triangle and do that. So this is what I'm going to do. I'm looking at the blue triangle, and I know that the tangent of 46 degrees is equal to opposite over adjacent. So I can go ahead and solve and do 100 divided by tangent of 46. And so D is about 96.6 feet. Okay? All right, so then I can go ahead and plug that in here. And now I'm going to go with the big red triangle. And I can say that the tangent of 22 is opposite 100 over adjacent. And what is adjacent here? X plus 96.6. Right? Yes. Okay. Oh, thank you. And then we go ahead and we can cross multiply. Okay. So you get X tangent of 22 degrees plus tangent of 22 times 96.6. I went ahead and distributed. Oh, we did? That's okay. Equals 100. When I cross multiplied here, I distributed to both. Oh, you divided by tangent first? You could do that.
I took two different triangles and subtracted them.
Oh, and that works too. Yeah. Okay, so we'll do 100 and we'll subtract this tangent 96 whatever to the other side. So 96.6 times tangent of 22. Okay, and then I get X times tangent of 22 degrees equals 60.97, and then I'm going to divide by tangent of 22. Let's see if we got the same answer. I got 150.9. Yeah, good. So the car traveled about 150.9 feet. Okay, that one's not too bad. You set up two triangles, you solve. Sometimes if I get stuck on these problems, these word problems get a little tricky, I just start trying to solve for whatever I can, you know. If I know something, I just solve for it. And I might not need it, but I might also. All right, number 3. Okay, this one's even harder yet. Here we go.
How many are there?
There's 4.
Numbers so many?
Yeah, there's 4.
One letter?
Yeah, I skip simple harmonic motion. It's in the book, but we actually skip it. You'll get a little bit of it in calculus, but not much. So, okay, finding the height above the ground. It says here, a large helium-filled penguin.
What?
Yeah, it's like one of those parades that they have these huge, Macy's Day Parade. Is moored at the beginning of a parade route awaiting the start of the parade. 2 cables attached to the underside of the penguin make angles of 48 and 40 with the ground. Okay, so let's draw this out. Here's the penguin up here. I'm just going to draw it as a balloon. That looks like a sperm. Okay, here we go. Yeah.
Nobody was thinking I was thinking
No, we do. All right. Here we go. There we go. Nice. And then this is 10. They tell you that between these measurements, between the 2 cables that are holding the balloon is 10 feet. And then this in here is 40 degrees. That's a 40. Sorry. And then this over here is 48 degrees. Okay? And the question is, if the cables are attached to the ground 10 feet from each other, how high above the ground is the penguin? We're looking for that right there. Now this one's a little bit trickier than the last one. It's kind of the same. This looks like the car, you know, the distance of the car right here. And we were finding that in the last one. We don't know this right here either, this X. So what they do is they have you set up a system of equations, because there's 2 equations, I know. So let's do that though. Let's get our blue triangle right here. And we're going to write the tangent of 48 degrees is equal to opposite over adjacent. And then I'll do it in green this time for fun.
Wow.
There we go. We have that one too. So we can say that the tangent of 40 degrees is opposite over adjacent, x plus 10. Okay? So you have two equations with two unknowns. You have an x and an h in both of them. So let's go ahead and we'll solve for h, and then we'll set them equal to each other. Okay? So this one, h is equal to x tangent of 48 degrees. And over here, h is equal to tangent of 40 degrees times x plus 10. Okay? And now we can just set them equal to each other. So we have x tangent of 48 degrees equals, we can go ahead and distribute x tan 40 plus 10 tan 40. There's other ways to solve this too. We could have divided both sides by tan 40 right away. So this is what you need to do. You need to get your x's together. So we have x tangent of 48 degrees. Subtract that x tangent of 40 degrees here. It's equal to 10 tan 40 degrees. And then go ahead and factor an x out to the front. So we get tangent of 48 degrees minus the tangent of 40 degrees, which is not the tangent of 8 degrees. Don't ever say that. Equals 10 tan 40.
Why isn't it the tan 8?
Because there's actually a formula for the subtraction of two angles like that. It's not that. Okay. All right, and then divide by this big thing right here. Divide both sides. You can put the whole thing in your calculator. So you get 10 tan 40 divided by parentheses tan 48 minus tan 40. Close parentheses twice, enter. I hope that's right. Is that what you guys got? No. Oh, that solved for x. Ooh, good call. Yeah. So x is 30.9 feet, but I need to find the height, so I actually need h. And you can go back up to either one of these, here or here, and solve for h. So I would do 30.9 times tangent of 48. 34.3. You could have gone and plugged x into either one of those to solve for h. So h is equal to 30.9 times tangent of 48 degrees, which is about 34.3 feet. So that's how high the penguin is. Okay.
Why would somebody know that?
Oh, I don't know. For fun. Number 4. Okay, last one. All right. Using trigonometry in navigation. Whew. It says a U.S. Coast Guard patrol boat leaves Port Cleveland and averages 35 knots. That would be nautical miles per hour. 35 miles per hour, nautical miles per hour, but we'll just write miles per hour. And traveled for 2 hours on a course of 53 degrees. Okay. And then, so that's the first part, and then he traveled for 3 hours on a course of 143 degrees. What is the boat's bearing and distance from Port Cleveland? This is a really tough problem.
Oh, Ram was complaining about this.
Really? Oh, yeah, they've done this already. She mixes it up a little bit. Okay, here we go. So here it is. They give you a picture over here, which is nice. They call this point A. And so 53 degrees from the north. Remember, we did this at the beginning of the chapter. If you're traveling at a 53 degrees, that would be from the north, you're going an angle of 53 degrees. So that's the guy's path, okay, for a while, for 2 hours. at 35 miles per hour. Then he switches and he goes at 143 degrees from the north. So 143 degrees is about to here maybe. He switches direction and he goes on this route for 3 hours. Okay?
Maybe going down more. Does it matter?
143, yeah, maybe a little bit down more.
Because like your angle that you have to turn at.
Yeah, you don't like that angle there? You like it more like this?
Yeah, like the arrow
No.
would be connected to like the ray, right? That,
Well, yeah.
Wouldn't it?
Yeah. So that's 143 degrees. This is 53 degrees here. Okay. And then this is C. They call these different things here. And then they draw a line from A to C.
Where did B go?
B's up here.
Oh.
That is a 90-degree angle.
What? Not look like
What?
Red.
A ship can't turn at 90 degrees.
Beta, alpha, theta. They put a bunch of Greek letters in just to confuse you even more. All right, we've got 7 minutes. We can do this. Okay,
Okay.
here we go. It says here in the diagram, oh, we'll call this B. This is point B up here. Yeah. In the diagram, line AB is a transversal that cuts a pair of parallel lines.
Mm-hmm.
Then that means that beta, this beta inside of here, is 53 degrees also. Do you agree with that? See, I don't know that this is 90. I kind of jumped the gun on that. So beta is 53 because these right here are going to be
Oh.
cut. Yeah, alternate. They call that a transversal, and it's cut. So then this angle is the same as that angle. And then what's alpha then? Alpha is going to be 180 degrees minus, Jill, yay! You're going to break this time. 143, sorry. So then this right here, see how that angle is 143 and then subtracted from 180? Because 180 is the line going straight down, okay? So what's 180 minus 43? That would be 37. So that would make this in here a 90-degree angle because 53 plus 37, 90 degrees. So I didn't know that right away. I shouldn't have written that down, but it is. Now I know it. Okay, so here we go. What are we trying to find? We're trying to find the distance from Port Cleveland. So we're trying to find,
The hypotenuse.
yeah, hypotenuse. Yes, it is hypotenuse. Okay, so let's go ahead. AB, we have the distance of AB because the guy was going 35 miles per hour for 2 hours. So what's the distance on that? Distance equals rate times time? 70, exactly. So that's 70 miles right there. And then BC over here, this is 3 hours at 35 miles per hour, which is 105. And you actually don't need any trigonometry for this problem yet, do you? No. That's crazy, huh? Okay. 105, 70.
Wait, how did you do that?
Oh, distance equals rate times time. So they told me that for the AB, his distance is the rate. He's going 35 miles per hour, and he's doing that for 2 hours. So that turned out to be 70. And then for the green one, that distance was, he's still going 35 miles per hour. They didn't change that, but he's going at that distance for 3 hours, and so that would be 105. All right, now we need to find out what x is. Well, I can just use Pythagorean theorem, huh? A squared
We didn't even have to label any of that.
plus b squared equals x squared.
We didn't need any of those symbols.
Well, for the last part we do.
Oh, okay.
Yeah, there's one more question. There's 2 questions on this problem. Yes. All right, so 70 squared plus 105 squared. And then take the square root of your answer. And so his distance is about 126.2 nautical miles. You could just write miles. It's fine. Okay. Now it says to find the bearing from Port Cleveland to the boat.
Does that line cut like perpendicularly to that?
This one?
Yeah, to A to C. Like, does that make it
It doesn't. Mm-mm. Yeah, that would help though, wouldn't it?
That really would.
Yeah. So we're trying to find this angle here. No? See,
What's the question again?
Okay. We are looking for, let me do this in yellow. We're looking for this angle. I don't know which angle we're looking for.
I think they're looking for the displacement, so
Well, I know what the answer is. I just don't know which angle they want.
Are we looking for theta?
No. Well, yeah, you have to find theta. The angle that they're looking for is this angle right here, because that's the bearing that the boat's taking.
Yeah, okay, because if it like starts at A and it's facing
Yeah.
forward and then it makes both of its angles.
All right.
It's
Yeah.
from Port Cleveland.
It says from Port Cleveland. So Port Cleveland's here, and this is where the boat is, so that's going to be the bearing that the boat's on. Yeah, that makes
Should we
sense.
just find theta and
Yeah,
then
yep, we got to find theta.
Oh, yeah.
So, this is really good because we haven't done one like this yet. So, tangent of theta is going to be opposite over adjacent. And when you solve this, you have to do tan inverse. So theta is going to equal tan inverse,
I learned that.
of 105 over 70. And you get that theta is, I'm almost done, 56.3 degrees. And then you have to add it to the 53 degrees from the top. And that will give you the bearing. Okay, sorry about that. I wasn't sure what they wanted. There we go.